Hello, Sana. Am I audible? Hello, Sana. Am I audible to you? Please tell. Hamza, am I audible to you?
Yes, sir.
Okay. Sana, hello. Hello, Sana. Okay. Oh, okay, okay, okay. So, today we will discuss about the electric potential due to an electric dipole at a point. So, firstly, I want to tell you about the electric dipole, and this is a charge -2 here. A -2 charge is placed, and here a positive charge is placed, and these two charges are separated by a distance,
Small
some distance.
distance.
Okay, maybe a small distance. We can say I am supposing here the distance A. So this is the center. This is the center of this line. Okay, and the distance between the point O. This is the midpoint. The distance between the point O and this charge Q. Actually, this charge is a point charge. Okay, this charge is point charge. Point charge. What is point charge? Point charge is very small charge. Very very small charge. This, like this point. And a point, we can say a circle of zero radius. So, so this is the an electric dipole. Okay, the system of two charges which is separated by some distance. So this is a dipole. Have you heard about the dipole moment? Anyone?
Yes.
Okay, no problem. Dipole moment. So I represent the dipole moment with P. Okay, and the value of dipole moment can be calculated. We can take any of the charge. Any of the charge means the magnitude of any charge and distance between these two charges. What is distance between these two charges?
2A.
2. Very good, very good. Please, if you have any problem, please ask me. Okay. So we are going to use this thing in the next derivation. Okay. One thing more I want to tell you. Suppose I have a charge Q here. This charge Q is placed here, and I want to calculate the value of potential at point P, which is at a distance of R. So can you please tell me what will be the potential at point P due to this positive charge? Okay, I am telling. So the value of the electric potential at this point P, which is at a distance R from this charge Q, will be 1
1 by
upon
4 pi
4.
epsilon 0.
Very good. Q divided by R. Okay.
So it should be R square, right?
No, no, no. It is not R square. That is in the case of electric field or force. Okay. Fine. Hello, Hamza. Fine it. Is it fine?
Yes, sir.
Okay. Okay. So these two things we have to remember, and I will use these two formulas, these two concepts in the next derivation that we are going to study. So Please, if you have any problem, you can ask me. So now electric potential due to dipole. Fine. So these are the 2 points, and here the minus q charge is placed, and here a plus q charge is placed. And in the same way, the distance between these two is like this, A, and this is the center. And we can calculate the value of potential at any point around it. Okay, we can calculate the potential here due to this dipole. We can also calculate the potential here, here, at all the points. So I am calculating the potential at some point P from there, from O, and this makes an angle theta with this line of dipole. Okay, okay, guys.
Yes, sir.
Okay. If you have any problem, you can ask. This is actually now, this is a basic thing. So this OP makes an angle theta with this. We can consider it as A, and this, the location of point is at A and the location of point is at B. So, and we have to calculate the value of potential at point. Okay, this is our problem, and we have to find the solution. Okay, so what I will do here, I will join A to P and B to P. Okay, this is actually BP is a straight line. This BP is a straight line. It is not looking like a straight line, but BP is a straight line. Okay, so, and one thing more, this distance is R, and this distance is R2. I am taking this distance as R2, AP as R2, and BP as
R1.
okay. Okay. Any problem? Okay, fine. So what happened? We have to calculate the potential at point P from the center of dipole. So what we have done? We have done the construction. We have done the construction. So as to solve the problem. So as to solve the problem, I join A with P and B with P. Okay. So now, due to charge at B or due to charge at A, what is the potential at point B? What is the potential at point B? We can use the formula as I have told you earlier. B equal to 1 upon 4 pi epsilon naught divided by Q by R. Okay. So here we can take minus charge. Okay. Here, due to this minus charge, what is the potential? What will be the potential here? 1 upon 4 pi epsilon naught, and this will be minus Q. This is epsilon naught minus Q divided by R. This is R, not R square. Okay, thumbs up. Okay. So this is the this is due to charge at A. Charge at A. This is the potential at point P due to charge at A. Okay. So I am writing 1 upon 4 pi epsilon naught equal to K. Okay. Can I write this? KQ minus R. I have replaced this with K. So what is BA? BA equal to minus.
Sir, your voice is breaking.
Okay, my voice is breaking. Okay. Now it is clear. Hello. Give me a
Yes, sir,
minute.
now it's clear.
Okay. Now, if you have any problem, you can tell me. Yeah. Okay. So we can write here. You have understood these things. Sana and Hamza, both of you have understood these things, na? Have you understood these things? Okay. Okay, fine. So,
Sir, I'll take a 5 minutes break. I have to pray. I'll come back after 5 minutes.
okay. Should I stop?
Yes, sir, I'll come after 5 minutes.
Okay. Hello, Sana. So, I think, okay. So, I am taking a break of 5 minutes.
sir,
Am I audible?
yes, sir.
Okay, let's proceed. Okay, so we can write VA as minus KQ divided by R. Am I audible?
Yes, sir, you're audible.
Okay. So we can calculate the value of VV. Similarly, V at point B there is a positive charge, and this positive charge is at a distance R1 from this point P. So we can write K Q divided by, this will be actually R1 VA. This will be actually R2. Okay, R2 R2. This will be KQ divided by R1. Okay, so as potential is a scalar quantity, so we can calculate the potential at point P as VA plus VB. We
VV.
can add the potential directly, VB. Okay, directly without considering the direction. Okay, so this will be minus KQ divided by R2, and this will be KQ divided by R1. Okay,
So we'll take K common.
yeah, of course, we will take. So from here, we will take this KQ, this KQ common. Okay, from here, we will take this KQ as common. So we will have minus 1 upon R2 plus 1 upon R1. Okay, okay, fine. So we can write VP as KQ. Can I write this expression as 1 upon R1 minus 1 upon R2? Okay, Hamza, is it okay? So, so from here now, this is the resultant potential. This is the resultant potential at point P. There is the resultant potential at point P due to this dipole. Now we will calculate the value of this expression 1 upon R1 minus 1 upon R2 in terms of A theta and R. Okay, A theta and R. So have you noted down?
No, sir, I will not write it.
So would you write?
I have it written in my book already.
Okay. So uh, we will do the construction again. Okay, we will do the construction again. I am drawing this diagram again. So this is a point, another point. This is charge minus Q, and this is plus Q. Okay. And this is the point P. This is point O, and this is point P. Okay, and this makes an angle theta. So this was R2, and this was R1. Okay, this is R1. Sorry. Okay. So what we will do now, this is R1 and this is R and this is A and this is A. We will draw a perpendicular from this point. This was the point A and this was the point B. We will draw a perpendicular from this point B to this OP. Okay. We will draw the perpendicular. Now perpendicular from here to here. Okay, we can, sorry. I am drawing the perpendicular like this. Okay, this is the perpendicular, Hamza. Okay, to this line OP. Okay, from
Yes.
point B. Okay, so this angle will be 90 degree. Angle, I am giving the name of this point as N. This will be 90 degree. This angle will be 90 degree. So now what we will do, we will convert this R1 in terms of A and theta. So this is a triangle. This is a triangle ON and B. This is a triangle O N and B, and this is perpendicular. Okay, this is perpendicular. So opposite to the perpendicular, this is hypotenuse. Okay, and this is the angle theta. So this will be base. I am representing B for base. So from here we can calculate the value of cos theta as, what is the value of cos theta? Hamza, can you please tell me? Hello. Hamza, am I audible to you? Hello, Hamza.
Yes, sir.
Am I audible to you or not?
Yes, sir, you're audible.
So what I am asking to you, please tell me what is the value of cos theta? Cos theta is base divided by hypotenuse, and what is base here? ON.
Base is ON and hypotenuse
Hypotenuse
is
is
OB. OB. Yes.
okay. So ON, this is ON, and OB is A. Okay, OB is A. So from here, we can calculate ON. ON equal to A cos theta. Okay. From here we can calculate ON equal to A cos theta. Now I have drawn the perpendicular here because I want this PN and this PV to be equal. Okay, Pn, I have drawn the perpendicular in this way that Pn is approximately equal to PV. PV that is equal to R1. Okay, Hamza. So Pn, from here Pn can be written as OP minus On, and it will be equal to R1. So OP is R, here OP is R, and On is A cos theta. This is the value of R1, R minus A cos
So
theta.
your voice is
Okay.
breaking.
Okay. 1 minute. Then now it's okay.
Yes.
Okay, fine. So have you understood till here? What is the value of R1? R1 equal to R minus A cos
R minus
theta.
A
Okay,
cos theta.
very good, very good. So in this way we will do the derivation. Actually we are studying the physics, so we have to do some mathematics also. Okay, so in the same way we will calculate the value of R2. Okay, for R2, uh, have you noted down this? Should I erase this? Have you understood?
Yes, sir. Yes, sir.
Should I erase this?
Yes, sir.
Any problem with this? Okay, okay, fine. If you have any problem, please tell me. So I am erasing this because we will use this result. This result only. Okay. In physics, understanding is important. So now I am extending this OP. Okay, like this, like this. Okay, I am extending this OP like this and drawing a perpendicular from here to this extended OP. Okay, drawing a perpendicular from point A to this extended OP. So now here is a triangle. We have a triangle, and one thing more. This PA will equal to PM. I am considering this point PM. I am drawing the perpendicular like PA should approximately equal to PM. Okay. So here,
Yes.
okay, fine. If you have any problem, please tell me. PA will approximately equal to PM. Okay. And what is PA? PA is R2. PA is R2. And PA, this is actually approximate sign. So we can say, we can convert it into equal sign also. Okay. So R2 PM. Now, what is the value? We can write PM. How can we write PM? PM can be written as OP plus OM. Sorry,
Yes, sir.
my internet connection is not okay. So here again we will calculate the value of cos theta. This angle is theta, so this angle will also theta. Okay, by the symmetry, this angle will also be theta. So from here, this angle is 90 degree, and this will be the hypotenuse, and this will be the base. So what will be the cos theta? OM divided by OA. So this will be the theta. So cos theta will equal to OM divided by OA is equal to A. Okay. So we will use this. So from here, OM can be calculated as A of cos theta. Okay. So now we will put this value of OM here. Okay. Here we will put the value. So what we will get? R2 is equal to OP.
R plus A cos theta.
Very good. OP is R. OP is R plus A cos theta. So we have R1 and R2 in terms of RA and theta. So we will use this expression for calculating the potential. Okay. So potential at point P for KQ 1 upon R1 minus 1 upon R2. This was our earlier expression. This was our expression. Okay. So we can put here potential at point P equal to KQ 1 upon R minus A cos theta minus 1 upon R plus A cos theta. Okay. So from here, I can calculate VP as KQ, and what will be the LCM of this? What will be the LCM of this? The multiplication of these two terms. Okay. So the multiplication of these two terms. Hamza, am I audible? Hamza,
Yes, sir, you're audible.
and if you have any problem. Okay. So we can multiply these two, and the result will be A. We can consider it as A minus B, A plus B. So this will become A square minus B square. This will become R square minus A square cos square theta, and this will be multiplied by 1. So this will be R plus A cos theta, and with negative sign, we will multiply minus 1 with R. So this will be minus R, and this will be minus minus plus. This will be A cos theta. Okay. So VP is equal to K. R is cancel out. Cos theta divided by R square minus A square cos square theta. Okay. Q into 2A cos theta divided by R square minus A square cos square theta. So what is Q into 2A? Q into 2A is the value of dipole. So we can write it as Kp and this is r square minus a square cos square theta. Okay, so this is the final expression for the dipole. Hamza,
Yes,
is
sir.
it clear? Is it clear till here?
Yes, sir.
Okay, fine. So so this is the expression. This is the expression for the dipole. This is the expression for the potential at point P due to dipole, which is at a distance r from the center. Okay, so this is our final expression. And now, uh, have you heard about ideal dipole? Had you have you heard about ideal dipole, Hamza?
Yes, sir.
Okay, so what is ideal dipole?
I don't know, sir.
Okay, okay, no problem. So ideal dipole is basically the distance between the charges is small. Okay, distance between charges is small. So we can say that A is very small. Okay, A is very small means A is very much small than R. Okay, so this is the ideal dipole. This distance is very small. This distance may be in picometer, and this will be in centimeter. So compared to this, the distance is very small. So with this, we can eliminate this term. We can eliminate this term because A is very small. If we square the small term, it will become more small. Like if we, this is a point 0.1 is a small. Okay, so I am, if I am, this will be 0.1. So it will become more small. So from here we can write r square minus a square cos square theta. I am doing this because this is like I have written 10 to the power 5 minus the, okay, fine. So I can write this. So for the ideal dipole, we can calculate Bp as Kp cos theta divided by r square. Okay, dipole, ideal dipole, potential due to ideal dipole. Okay, fine. This is the expression for the potential due to ideal dipole. So I am moving forward. So case 1. Case 1. Suppose this is a charge q minus q and this is a charge plus q. Okay, and same thing is there. The center, this is A and this is
Sir,
B.
your
And
internet connection is bad. Your voice is breaking.
okay, Hello, Hamza. Now I'm audible. Hamza, I'm audible to you. Now it's okay, Hamza.
Sir, your voice is breaking. Something happened to your internet connection.
Oh, okay. Please wait a minute.
Hello, sir.
Hello, hello, Hamza.
Yes, sir.
Now I am audible.
Yes, sir. Yes, sir, you're audible, but there's still a problem with the internet connection. Your voice is breaking.
Oh, okay, sorry for that.
Okay, now it's fine.
So actually, I think there's a problem in the internet. Hmm, Please give me 1 or 2 minutes.
Sir, will the class resume?
Sir, hi, hello.
Yes, sir.
I am sharing my screen, and
Sir,
please
your
tell
voice is
me
breaking again.
if it is visible to you. My screen is visible to my voice. Okay.
Yes, yes. Yes, sir, your screen is.
Hello. Hello. Hamza.
Yes, sir.
Now my voice is clear or not?
Yes, sir, it does.
So can we start? Okay.
Yes, sir, we
So
can.
I okay, if I want to calculate, if I want to calculate the value of potential, if I want to calculate the value of potential at this point, at the axis of this dipole, okay, if I want to calculate the value of potential on the problem, so you can message me also on this, and you can tell me also. Okay, fine. So for this, for this, uh, the theta, what will be the value of theta? Now this will be the theta, and now this point P comes here. This point P comes here. So theta will equal to 0 degree. Theta will equal to 0 degree. So we can calculate the value as, sorry, hello.
Yes, sir.
So let's proceed. So I can
Okay.
write it as Kp, and this will be the cos 0 and divided by, I have written here, okay, divided by r square. Okay, and Hamza, please tell me what is the value of cos 0?
Value of cos 0 is
Kp divided by r square,
yes 1.
1.
So it's
Fine.
1 by 4 pi epsilon 0.
Okay.
And
Yes, yes. This
p
case,
by
this
4 pi epsilon 0 r square.
very good, very good, very good. So now I am moving with the next case. So suppose if I say this is minus q and this is plus q, and this is separated by some distance, point, and this is A. And if I want to calculate the potential at this point P, which is the perpendicular bisector of this, okay,
Mm,
this dipole, okay. Now it's very
yes.
easy. So here what will be the value of theta? Here theta is equal to 90 degree. Okay. So
Yes.
I am putting theta as 90 degree, and we will use the same formula, Vp equal to Kp cos of 90
So it
degree
will be zero, sir. Cos 90 is zero, so it will be
divided
V
by,
is equal to
very
zero.
good, very good, very good, very good, very nice, very nice, very nice. So this value will be 0. Okay, this value will be 0. So it means that this value is 0, and we say this, that this is the potential. This is the value of potential at equatorial, equatorial or perpendicular bisector of dipole. Okay. So actually, the thing is that this point is the, this is the location of perpendicular bisector. If we draw a straight line 2.0, 2.0, okay, and this is the distance r 2.0. So this will divide this distance into two equal parts. Okay, so that is why it is called as perpendicular bisector. What is the meaning of perpendicular bisector? Perpendicular bisector means, suppose this is a line of length 2l. Okay, and if I am drawing a perpendicular bisector, means it will divide this line into equal distances and will make the angle 90 degree with this line. Okay, fine. Hamza, fine.
Yes, sir.
Please tell me if you have any problem. So uh, uh, from here, what we have studied. So I have told you about the electric potential due to the electric dipole at any location theta. Okay, for any location theta, we have calculated the electric potential. Okay, I have derived this thing. Okay, and finally we got this formula. Finally we got this formula, Vp equal to Kp cos theta divided by r square minus a square cos square theta. And after that, we have convert this formula as Kp cos theta by r square for ideal dipole. Okay, for ideal dipole. Okay, and Hamza, one thing more, if you want to note this on your notebook, so please tell me.
No, sir. No need.
Okay, okay, that's fine, that's fine. If
Okay,
you
sir.
don't want to note, that is okay. So now my voice is clear. There is no issue.
No, sir. Your voice is fine now. The internet is normal again.
Okay, 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 thank you, thank you. So and I have told you the meaning of ideal dipole. Ideal dipole is the when the distance between the two charges will become very small, and this will become the ideal dipole. So this distance A is very small. A is very small means A is very small from R. If we square this A, okay, if we square this A, this will become very small. So if we subtract this A square cos square theta from R square, so it will approximately will become equal to R square. So I have given you an example. This is just for understanding. Okay, this is just for understanding. So now we have got this formula, Kp cos theta divided by r square. Okay. So after that, I have told you the case one. Case one. Case one, we can say this is the case one when we have to calculate the electric potential at the axial line. Axial line means line of this dipole. If we want to calculate the potential at line of this dipole, and this is at a distance of r, okay, so please remember this thing, okay, please remember this thing. This point P is at a distance r from the center of dipole, okay. So we have this formula for that. And for the equatorial point, this point is the equatorial point. For this point we have the potential zero, we have the potential zero, okay. So two things you should remember for the numerical purpose, okay. So now we will move towards the numerical, okay. If you have any problem till here, please ask me. Any
No,
problem
sir. Understood. No,
in
no.
the above derivation, because we are studying the physics, okay. So
Yes.
there can be the problem, and there should be the understanding of physics,
No,
not
sir. The problem is not in
not
derivation, but numericals. There's a problem.
yeah,
Like what should be in what
yeah,
place? Yes.
okay, okay, yeah, yeah, of course I can understand that. So this is the thing, okay. So now uh, I am moving to a numerical, okay. And if again I am saying, and sorry for the internet connection at that time. So we have a numerical, okay, Hamza, we have a numerical, two charges minus and plus q are placed at 0 comma 0 comma minus a and 0 comma 0 comma a respectively, okay.
Yes, sir.
Now we have to calculate the first part of the question is potential at point A. Potential at point A, and the coordinates of A are given as 0 comma 0 comma some z, okay. And second part is potential at point B, and the coordinates of B is given as a comma 0 comma 0. Fine. And the third part of the question is calculate the work done in carrying a proton from A to B. Okay, from A. Our question. This is our question. Okay, Hamza. So this
Yes.
okay. This is our question. And sorry for the internet. And solve this. Now we will solve this. So for this, uh, suppose this is y-axis and this is z-axis. Okay. So Hamza, can you tell me the location of 0 comma 0 comma minus a, 0 comma 0 comma minus a? 0 comma 0 comma minus a. 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 0 comma 0 on which axis will be 0 comma 0 comma minus a? Hello.
Yes, sir. I don't know, sir. I don't know how to,
Okay, you
like, I
don't
don't
know.
understand that.
So I am telling. Okay, okay. I am telling you. I am telling you. The x coordinate of this point is 0. Y coordinate of this point is 0. Only this have the z coordinate. Okay. This have only the z
Yes,
coordinate. So this will this will lie on z axis. Similarly, for this point,
Z.
we can say that it, the x this has only coordinate x coordinate only. So okay, so it have the y coordinate 0 and z coordinate 0. So on which axis this point will lie? This point will lie on x axis.
X-axis.
Okay, suppose I am asking
Yes,
you, suppose I'm asking you, this is 0, this is 5, this is 0. So on which axis this
this will
point will
lie
lie?
on Y-axis. Y.
Very good, very
Y.
y axis. Y axis, very good. Okay, so in this way we can see that. Okay, so this is the positive direction of z axis. This is the positive direction of z axis, and this is the negative direction of z axis. And minus q charge is placed at 0 comma 0 comma minus a. Okay, this is, here is a minus charge, minus q charge, and this is placed at 0 comma 0 comma minus a. Fine, this is on z axis, and another charge plus q is placed at 0 comma 0 comma a. Okay, fine.
Yes, sir.
Okay, I am supposing this point as p and supposing this point as q. Okay, so this is very good numerical. So, and this is the center. This is the center. So this distance, OP distance is a, and O and QO distance is also a. Okay, Hamza, because this have on this has the value a, z coordinate has the value a, so this distance will become a, na? Okay,
Yes.
okay, fine. This distance will become a. This distance will also will become a, because this point is at a distance a from origin on z axis, and this point is at a distance of a from origin. This point also. So these two things are clear. So basically, what you can see from here, basically this is a dipole, no? This is seems to be dipole. This is a minus q charge here. Okay, this is a plus q charge here, and these two charges are separated by some distance. Okay, these two charges are separated by some distance. So this is a dipole. Okay, and now we want to calculate the value of potential at point A, and A is given at 0 comma 0 comma z. So this point will lie on z axis. Hamza, this point will lie on z axis. So I am supposing, uh, sorry, I am supposing, okay, I understand this, and supposing this point A is lying on z axis, and whose coordinate is given as 0 comma 0 comma z. Okay, so it means that this point A is at a distance of z from origin. Okay, is at a distance of z from origin, z from the center of this dipole, we can also say. Okay, so now we can see that this is the axial point of this dipole. This point lies on the axis of this dipole. Okay, this point lies on the axis of this dipole. So for the axis of dipole, we have the formula. What the formula we have derived? Kp divided by r square. Okay.
Yeah, P cos.
Kp divided by r square. I am taking here this is the ideal dipole. Okay, this is the ideal dipole. I am taking this as a ideal dipole. So we can calculate the value of P. What is the value of P? Q into 2a and r square means this this will be the distance z square. R here r is that. Okay,
Yes.
r is that because r is that. This will be z square. So the potential at point, this is the potential at point A. Okay, this is the potential at point A. Now we will calculate potential at point B. So the location of point B, this is a point B hamza, and the location of point B will be on this axis, on x axis. Okay, a comma 0 comma 0. So the location of this point B is on the x axis, and these three axes are perpendicular to each other, means this line and this location is perpendicular. OB is perpendicular to this dipole. Okay, so B is the equatorial position. B is equatorial position. Equatorial position. And what is the potential at equatorial position? We have calculated 0. Okay, we have calculated 0 like this here. This is the case. Okay, we have calculated the value of potential as 0. Fine. Hamza, fine.
Yes, sir.
Okay. So this is the last numerical, and this is the last part of the numerical I am solving. So we have calculated potential at A. We have calculated the potential at B. Now we are going to calculate the work done. We are going to calculate the work done when a proton is taking from A to B. When a proton is taking from A to B, what will be the work done? Okay, what will be the work done? So formula of work done. I am supposing this potential at B. Okay, so how much work I have to do? How much work I have to do? Okay, that is the thing. That is the thing. How much work I have to do? So, so formula of work when a charge Q is moving from point A to B, so we can write it as potential at point B minus potential at point A. Okay. So for this case, we can calculate the work done equal to, and the charge on proton, is equal to E. E equal to 1.6. Writing the charge in the form of E only. Okay. So here I will put E, and the potential at B. Potential at B is 0 minus potential at A. Potential at A. What is the value of potential of at A? This is the value of potential at K Q into Z square. Okay. Minus value of Q into 2a. This will be the value of dipole. Okay. This is Z square. So from here, work comes out to be minus E Kp divided by Z square. Okay, this is the final answer. Hello, Hamza. So this is our numerical, and this is our final answer. And I have tried my best to explain you. Have you
Yes, sir.
understood?
Yes, sir.
And if you have any problem, please tell me.
No,
And
sir. Understood.
okay, so we have 5 more minutes. So in these minutes, I am explaining what I have taught to you. So we have calculated the electric potential due to dipole. This is a dipole. Okay, this is dipole, and we have calculated the electric potential at point P, which is at angle theta and at a distance r from the center. So the formula for that, we have got the formula Vp equal to, we have got this formula. Okay, we have got this formula, and no, this formula. We have got this formula. Okay, this formula, and we convert this formula into this formula by considering the concept of ideal dipole. Okay, I have explained this also to you. Kp cos theta by r square. Okay, and we have considered the potential at point P, and this point P lies on the axis of this dipole. So we can say that this is potential at axial position. So we can also say that this potential is the potential at axial position. The formula for
Yeah.
that, Kp divided by r square. Okay, and for
Yeah.
the, okay, for this equatorial point, for
Equatorial
this
position.
equatorial point or equatorial position, we have calculated the value of potential as 0. Okay, so I have told you
Yes.
the concept of what is perpendicular bisector, and after that I have explained you the this numerical. I have tried to explain this numerical. Okay, so this is the thing. First, we have calculated the potential at point A. After that, we have calculated the potential at point B, and after that, we have calculated the work done when a proton is moving from A to B. Okay, so this is the thing, and I have tried my best. And due to some internet issue, may you have got some problem, and so sorry for that. Hamza, please give me some feedback for this. Have you understood?
Yes, sir. Understood very nicely.
Okay. Uh, so now you can leave the meeting. Okay.
Okay,
And
sir. Thank you.
okay, thank you, Hamza.